No, it sucks. It sucks with this thing. Hold on, let me see. Let's try maybe this. Much better. Alright. Hello, welcome to Vietnam. Actually, hi there. So, I made myself a pot of coffee, which means last time I made tea and I got really sleepy and the live stream just bombed. Or was it 2 days ago? I don't remember. Time is a construct of the human mind anyway. Anyway, this time I have made coffee, which means that I'm going to be awake and alert and... My goodness, it takes... I'm stalling right now. I'm stalling because I'm trying to organize my entire... There we go. Stall over. We're back. So... Today we'll be working on Mathnimations, let's call it. I don't know what to call it exactly. It will be... well... I want to create a system, something which I really should have done a really long time ago, but I haven't. Which is... I really want to create a system, an animating system, an O-tree, for math equations. And so that's what we will do. Maths. Okay. And in order to do it, first we're gonna need sources, because there are special characters which we just won't be able to replicate. Oh my goodness, why is my throat giving out right at the beginning of live stream? Now is not the time. There we go. Okay. So, how are we gonna go about this? So glad no one asked. We're gonna create a cube, as always. It always starts with a cube. Arrow, and then you suppose, I don't know what to call them. Takes appear this arrow, all of them right here. Splendid. Okay, brilliant. So now what we get is this cube, which will be our equation. That's not how you spell it. Equation. Splendid. And for the equation, all I would like is... oh, so many things. It's just a lot. Basically... Hi, Leviander. Hi. Welcome. First, let's start with something simple. And by that I mean... whatever I use for text. This. Right here is what I use for text. However, very crucially and importantly, it should be noted that my goodness, that's an old setup. We can remove these. And yeah, it will use a string, but there's just going to be a string. Splendid. Make group, like so, and this will be as such. Test. Now I need to figure out, as I always tend to forget, what LaTeX. No, I didn't name the I'm figure. Hi. How you doing? I need to figure out what font LaTeX is using, which I always forget. It was Computer Modern. It was one of these. I think this one. can see test x, y, z. No, it is not. Alright, good to know. It's because this one is italic. We want not italic. We want serif, not italic. Not extra slanted, just serif. Add the serif on the italic. Almost, that's almost. The problem is that right here we have like a very soft. I finally figured out how to change the language in the new version. Oh, that's good. Why is there no? Why is every single one that fits italic? No, sorry, this one is extra slanted. Extra Roman slanted. That's just italic. Right, good enough. You know what they say, when life gives you lemons, right? Oh, this is horrendous, no. Okay, but I think there is a difference between normal font and then the font that's used for LaTeX. So I think the font used for LaTeX is this one actually. Close enough. I mean, kind of. No. No. Jackpot. Absolute jackpot. Splendid. Alright. So we've got this. Now. Oh, this is gonna be so annoying. Squeezing out people's eyes, exactly, precisely. Now, hold on, let me ponder for a second. Okay, I have pondered. Here's how we're gonna slice this cake. We are going to try to animate a simple equation, which will be x plus y divided by z minus x. Fine, x by z, doesn't matter. This kind of equation. This is what we want to achieve, roughly, closely. Also, let's just chuck in like an exponent here and there, just for good measure, like this. Yeah, should be fine. There we go. That will be the goal for today. Very ambitious, I know. Let's try it. How can I slice the cake? First of all, let's have an x. There we go, portion already done. I work fast. Now let's try adding to it, to the right, a y. Well, in order to do it, we're going to create a new node. First of all, let me just rename this one from node group to just LaTeX. Good, because LaTeX text, I know I'm hilarious. And then I know a math node just to, there we go, standard. We're going to have, I actually need to think for this. Oh, what pain and suffering. I was expecting this to be a very simple autopilot kind of blended project. Not something I need to think on. Did you manage to listen to the audiobook and make it? I haven't, I know, I was supposed to yesterday, but I got distracted with all this stuff. And we ended up playing chess. We ended up playing chess with... we ended up playing 4-player chess with Atomic. And Atomic is a creature in 4-player chess, let me just tell you. Like, genuinely. We have never had a player in 4-player chess like Atomic. We were playing with Atomic yesterday in 4-player chess, and we found out that you can actually take a king in 4-player chess. I didn't know that. No one knew that. You played for like 3 hours, yeah? Because Atomic joined it was mental. We genuinely discovered this move. Queen takes king. That's a real move. It was incredible. Also, Atomic asking how do you draw arrows and then pressing the draw button was also really funny. Atomic is just a player. There's no other way to describe it. Just a player. I've got it! Okay, I have an idea. We're going to do this, we're going to do this, and we're going to do this, and then we're going to do new node, switch. A, B, and the name of the node is going to be position. There we go. And now the goal will be that I want to use this node in order to position things. Switch on none of your business. There we go. Alright, and this will have options left, right, bottom, top, and corner. Those will be the three options. Basic idea being that this will allow us to, henceforth and as such, I'm really thinking about it way more than I should, I think. There we go. How is everyone doing, by the way? How are you all doing on this fine day? Splendid. So first let's do left and right. Left and right will mean top, ascend the corner. So we have two boxes. They originally start center. We need to move this one to the left by a certain amount. Yes. We need to move that one to the left by a certain amount. That amount will be half of its position. Yes. Vector math. And the maximum subtract the minimum. Divide by 2. And then I think, if I'm not mistaken, if I do transform geometry, this should move the cube, the x to the left. No, it didn't. Just maximum divide by 2? No, because it pushes it in its own direction. I'm such an idiot. Oh, even then we shouldn't do minimum. Right. Yeah. We should first normalize this, which means we add them together, like this. We subtract this from whatever we have, so we subtract minimum, and then this should move it to the left. Yes! And if we mimic the same exact setup for the y, however, this time with the y having, instead of subtracting the minimum, we subtract the maximum. That's a plus, that's not the y, right. And also the maximum is moving up. Of course, that's very reasonable. Very, very reasonable, I would say. There we go. I played the Gursa part of the game today. It was one really good soundtrack. Now that is in the charty Checkup channel. Alright, let me see. Hold on, I don't want to play it on stream and get copyright stricken, so I will just download it and play it myself. Oh my goodness! Oh my goodness! Yeah, I mean, obviously, point-and-click adventure game from 1995 has a soundtrack like this for one of its chapters. No, hold on, I take it back, I'm gonna play it on stream, because this is incredible. Yeah, a point-and-click adventure game from 1995 has a soundtrack like this for one of its chapters. Obviously, color me surprised. This is such a high production. I mean, come on. Ridiculous, absolutely ridiculous. Absolutely ridiculous. Okay, but the first one works. Now all we need to do is just figure out the other two. It's so good. It's ridiculous, is what it is. Absolutely ridiculous. There we go. And then the last one will be original object, I would say, in the same exact position. Just the other object that will be scaled down to 0.4. And then we actually need bounding box on the other one. There we go. And then what do we need from this bounding box? We need the maximum, right? Yeah, we need to move it in relation to the maximum points. This and these two. So multiply 1, 1 like this. And then we're going to have this. Which will multiply all of them. There we go. So now what this allows us to do is... Oh, why are you standing at 0.1? No, that's bad. Damn it! Why do you always have to be like that? Ah. Hi Leo, hi, welcome. Oh, it's 1, 1. And even then... maybe 0.1 would be a smarter choice. Or maybe even less. Yeah, I suppose. Alright, good. So, we have our 3 positioning options. Position left right, position bottom top, and position center corner. Hello, hi Leo, hi. How you doing? How's it going? Which means that now, what we need to do is animated positioning, but also we need to figure out positioning around the origins. It's been good, glad to hear, really glad to hear. Okay, good. We might need more. We have left right, but then past the left right we want to figure out what is the origin. How fake. Where's the first? Yeah, I had to reply to someone, don't mind that. By default, right now, it centers to the middle. We may not want it to center to the middle, however. We may want it to center around a specific object. And I think the only way to go about that would be we can just add more options. So we can add append right, append bottom, append top. Ah, that's a bit annoying actually. Well, could be worse. My God, I'm thinking about it a crazy lot. For what purpose? Well, it's because I want it to be clean. I'm glad I can answer my own questions. It's really convenient to sometimes just cut out the dialogue and just focus on the monologue. Yeah. Right. I think the best way to go about this would be to just add more options. Maybe not the best, but a way. So we'd have append right, append left, append bottom, append top, and if in the future we want more, then we'll do more. 4, 5, 6. I'm gonna head down and study. Alright, bye Leo, bye, good luck studying. Keep working hard, mom. That's I don't know why that motivates me. Hey, it's a widely known fact that that's a simple way to actually get to me positively. Keep working hard, non-binary parental figure. Okay, let's move this down. If we do actually expand these options, that means we should go through all of them, which will be a pain. So we're gonna have 7. Can I do index switch that takes in a menu as an option? My goodness, Blender is madness. Oh, how did they even... This is wild. Alright, fine. I'll take it. This is what we'll do. It's gonna be 6, and combine XYZ is gonna go into X, and not this, only this is gonna go into X and Y, like so, and then this will go in right here, this will go in right here. Splendid. And then we're going to just test out all of the positioning options, like so. They obviously will disappear because, well, we still need to make them. So the next one will be, that's a scary amount of nodes. Yeah, that is, I'll be brutally honest, that is in fact nothing. This is very tame by my standards, especially considering how all of these are effectively geometry nodes. They're not like simulation nodes, repeat zones. You know what? I consider that to be a challenge. Let me look into some of my recent creations, if I have anything exciting. There is obviously the temporary simulation, which I don't remember how complicated this one was, but it's a temporary file for this is a temporary file which just simulates an interaction. It's actually surprisingly simple. It's not as bad as it could have been. Hold on. There, here we have a full animation in case you're curious. Would make for a pretty nice screensaver. No, as a concept it is surprisingly simple because it runs on Newtonian mechanics, which are devilishly easy to implement. So this simulation right here has no conservation of energy, no conservation of momentum, and I've only geometry nodes and weight painting like plague. Weight painting is good. Hey, I don't have anything against people who don't utilize geometry nodes because they only have a very specific purpose. When it comes to the problem with Blender is that knowing how to use Blender is way too much of a blanket term. Blender is a tool for creating organic graphics, inorganic graphics, for modeling, for designing, 3D printing, for designing things in general, for rigging, for so many things. And I am really good at Blender when it comes to inorganic design. That's what I'm good at. When there are people out there who, even though, so for example, All Matter, despite having very little experience with Blender in comparison to me, I imagine All Matter would be way better than me at organic Blender design. Despite how much time I've spent in Blender. Right, so we're going to have a couple more because the next one will be append right. So what we want for append right is we want the, oh lord, append right will be easier than with this, same append left. Actually append left will be easy to modify from append right. Append right means that we want the X to start in its original position and we want the plus to go to the right. That's actually really simple. Huh. What am I talking about? That's so simple. X stays itself and then we just extract this. Well, if you use the correct goddamn thing. Alright, fine. We can multiply. Or I guess we can't. Incompatible standards because someone's an idiot. If I just do this. Oh, never mind. I'll be damned. It has to be a 2. Yeah. I'm an idiot. Right, there we go. So this absolutely works. And then for append left, it's going to be the same exact thing. The only difference being that it's obviously reversed. So this goes here. This goes here. This goes here. This goes here. But x we want to be to the left of it. This is the plus, right? No. Well, I'll be damned. Plus. Wait, no. This is correct, that's the x, yes. But x we want to go to the left, minimum. Yeah. Yesterday, end of stream, you said you needed to work on your control stream. This is good. I was like, I didn't think about more charity legal stuff, so I don't dox myself. It was both. it was both. But I will be honest, in this scenario it was more about the... it's not really, I don't talk about my roadmap, I just find it more fun when certain things are a surprise. I think it's more enjoyable to have like a positive surprise than if I actually... Because the thing is, behind the scenes, a lot of things we're working on behind the scenes end up failing. And that's normal. We're doing something completely new, you know, it's absolutely expected. But still, would be quite disappointing if I shared every single failure. Or every single project that ends up being a failure. This is good, because this works. Now we can just mirror the setup, but this time for the last two, which is append bottom and append top. And for append bottom, obviously it's going to be this. Wait, no. Why am I append bottom? Because we want all of them to be the same. X has to be at the top. No, it's like this is so. Let me just change this a bit to make this more readable. A B, A B, A B, A B, A B, A by B. Right. It didn't help. A has to be. Let me also draw just for the sake of convenience. Just so I remember. Just so I remember which one is which. Zero, zero, go to 10, 10, that should be fine. Right, so this line right here goes to the center of our things. One thing I'll do though is in the LaTeX, I'll just put it to the middle, but there we go. This goes through the center point of our text, which means that first we're starting with left-right, which puts the first element on the left, second element on the right. Then puts the first element on the top, second on the bottom. First element in the middle, second as the corner. First element on the left, second on the right, but the left element is the center point. Here the same thing, but with the right element center point. This is correct, which is, I think, is it correct or is the opposite of what I want? This should be append bottom, which means B has to be lower down. Which means instead of maximum, we just plug in minimum. But for some reason, it's improperly distanced. Why? Why do you like this? Well, this would happen if this bounding box came from B. No, it comes from A. That's correct. I don't know why that happens. Both of them are messed up in this scenario. Why would this be a free? Doesn't make sense. See, this is a pickle, because right here it worked just fine. Hi Darenko, how you doing? Right here was just fine. It makes sense, we're offsetting one of them. Wait, no, we're offsetting them by halves. It doesn't make sense. It doesn't make sense. Why would they overlap? Like, if we use the bounding box... There we go, you can see that the bounding box... We need the two bounding box. I'm such an idiot! Oh no! Oh no! We need half of the first bounding box plus the half of the second bounding box. Thank goodness I called it right now, because otherwise this would have been horrendous later. We can't just offset in relation to one of them. Oh, this is... Thank goodness I've called it. Alright. So... What we actually need is... delete all of these, because they're wrong. And then delete all of this, because it's wrong. Right, at this point it's append right, correct? Append right, yeah. Which means that A is in correct spot, B has to be offset as correct. But what we need then is we need A and B bounding boxes, respectively. Then what we want to do is we want to figure out their distance from the center, which means vector math. Add together both of them, divide by 2, subtract from the minimum, this is A, maximum, subtract this, copy the same setup, but this time subtract from the minimum, like so, and then add them both together? No, because one of the vectors is going this way, the other one is going this way. What we want is a vector is going this way, which means subtract, this one is going correctly, this one is going incorrectly, then translate. And then at the very end, 2 multiplications, because first multiplication has to happen x, y, z, and second multiplication has to happen beforehand, and it has to be just this. Because I am just that good at what I do. There we go. See kids, mathematics! Mathematics is useful. Linear algebra can be used in real life. And it is useful. Stay in school. There we go. And right here we do the same exact thing, except all we need to do is just very conveniently swap them around, if I'm not mistaken. Okay, not swap them around, but swap these around. And then... I mean, not swap them around at all, just swap these around. Yeah, there we go. No, because A is now the wrong way. There we go. Now it's correct way. Beautiful. Is it going to be about linear algebra? No, but I'm using linear algebra to prepare for it. Oh, this is a note that I should have done months ago. I'm glad I'm at least doing it right now. Okay. So there we go. And then there are only 2 remaining, which is the top-bottom alignment, which works in the exact same way. The only difference being that this time we pick a different axis. And so this would be correct, actually. No, it wouldn't, would it? It would not. It isn't correct unless we swap these around. I did not, in fact, swap them around. Now it is correct, because there's append bottom, yeah, and then append top is going to be very similar. Only difference being that we swap these around, and then we swap these around. Mathematics, beautiful. So, actually let me keep the equation on the left, because that's what we're trying to do at the end. So, what we have achieved here is actually a lot better than it looks, because what it would allow us to do is already position things properly for this thing on the left. Now what we can add is we can start adding operations. So we have the position node, we have the latex node. Then all we need We can delete everything at the top right here. It's irrelevant. Then what we need is we need addition, subtraction. Oh yeah, because another neat part about this position node is that if we position, for example, them like this, and then if we scale one of them down, it will still keep correct like proportions. As you can see, it aligns properly. And if we do append right, you can see it appears correctly, which will be very important for animating. Because with the latex, the way it's going to appear, it's obviously going to be scaled up or down. That's obviously. Oh my lord. It's fine, I can manage this. Next, what we need is we need operations. So position we're gonna keep just on its own, convenient node, but we will have another one that will be make group, and it will be the operations, which will have menu or switch. And for now, the menu switch will only be addition and subtraction. How about that? Addition, subtraction. That should be fine. And then we're going to have A and B. And let's say that we pick addition. In that scenario, if we do pick addition, then what we would like is a lot of things. I'm getting a headache. This is never as simple as it could be. Because, for example, trivially, theoretically, this should work if I just do this, right? Like this would be no, it wouldn't. Realize? Maybe? That could be the issue. No? Well, I'm fucked then. Alright, so that's bad. Because you really would expect the append right to just keep on working. As you can see, it's getting smaller and smaller, which means that something is clearly up. Good, that's good. It is improper. For the sake of debugging, append right, what is append right? Append right is this one. For the sake of debugging, let me just plug in bounding box right here. Okay, maybe not right there, but maybe like right here. We have this. Then we have that. Should be right here, should it not? No, it should be even better. My maths must be wrong. Why is my maths wrong? That's the question. Why is my maths wrong? This is not fun, because as far as I'm aware, the only solution to this I mean operations 1. Maps operations. There we go, fixed. I'm fine. So If this is wrong, that means everything below will also be wrong. However, the append does work differently from non-appending. So what I'm tempted to try is just remove this and first try it with left and right. Yeah, left and right is gonna work trivially. ABC. Oh, that is a problem. Why is there such a big gap in there? What happens if I keep adding left, right? Let me just keep adding left, right. That's a problem. That's a big issue. As you can see, it's nonsensical. The gap is increasing. Oh my goodness, I'm fine. I'm fine. This is simple mathematics. I can do it. I can do it. I've dealt with worse and lost to better. Okay. So the issue is, as we keep adding them, there's a gap that becomes more and more pronounced, which leads me to believe that the actual size isn't being offset properly. So what we want to do is, when we're centering, let me just delete up, let me just make a, I don't know, dot backup, and then let me just delete everything because it's all wrong. And let's get back to the basics. So what we want to figure out is by how much we need to move an object to the left in order for its rightmost point to be touching the center. This is correct. This is what you would expect. And yeah, we need to add that one. Yeah, this bounding box is basically correct, but as you can see, there is a distance right here, which is what we're trying to avoid. So let's try to fix it. Okay. We take the bounding box of an object, AB. Right. We add both of them together, we divide by 2. This gives us the center point of that box. Right here. Then, if we subtract from a minimum that center point, so for example, this vector, this is what the vector actually looks like. If we subtract from it the center point, what we get is just the vector aligned to the origin instead of the origin of the set element we're talking about specifically. So this is minimum goes left like so. Then if we multiply just by x, this is equivalent to just having this. So basically having vector size of half of this box. Oh, but if it's already pushed to the left, no, that shouldn't matter. Basically what we're interested in is, let's say we have some kind of, we have 2 angles like so, origin down the middle. We want to move the first one like this, the second one like this. The problem is that they don't have to be aligned themselves afterwards. That's true. That's the issue. So let's say that later on they look like this. In this scenario, it's going to move by this much. Wait, what am I doing? It should move this way. It should move by this much. We need to get maximum multiplied by -1. Yeah. And then this one has to be the minimum multiplied by -1. It still didn't work. Didn't do anything. Alright, great. Alright, back to square one. Go, and then the difference being that this is what we're going to do. Right, I ain't gonna work with the transforms. Which means what we need to do is we need to pass it twice, like so. There we go. No, I need to switch my music because this requires for something more extreme. This is what we get so far, which is clearly wrong. Wait, look at that. This is the origin, actually shifted to the right. And even more, what is this, huh? Oh, what is that now? What is that right there? That is incorrect. Okay, let's just remake the notes from scratch. Redo the maths. It's easy that way. Okay, so you have AB. We take the bounding box around each element. That's what the bounding box is. Then we add the two vectors together, divide by 2. Divide by 2 gives us the center point. Now if we go in and if we subtract from a certain value, because right now if we just plug in the minimum like so, this is what happens. It breaks completely, and the reason why it breaks completely is because those vectors aren't aligned properly. So now if instead of plugging it directly we do it like this, it's still not gonna be great, obviously. Now it breaks the other way. Okay, but the point is, this right here gives us the center point. If we subtract from our vector the center point, that will give us a cleaner vector. So we want to move A to the left. Let's try doing it. First of all, multiply 1, 0, 0 obviously on the x. Then if I do maximum, this is what happens, messed up. But if, first of all I do -1, better, yeah. Then beforehand I subtract this. This is close to being correct. Not that close, but somewhere. It's somewhere. Then we do the same one with the minimum on this side. Well, that's a problem because this moved to the right all of a sudden when it really shouldn't have. And the first iteration of the loop should just give us oh, because we plug it as the right. No. There we go. You can see the problem. For some reason, the gap is expanding, which means the gap would be based on the size of the bounding box in a way that's not supposed to. It basically corrects for its size when it shouldn't. That's basically the issue. We need to figure out why now. And just for the sake of clarity, let's do this. Now it's fine. Well, isn't that a curiosity? If both of them are equal size, it's fine. If they're not, then problems begin. Why? What if we get the total bounding box? Oh! Wait, that might be onto something. They're unequal after all. Well, no, that shouldn't matter though. Let's open the B's because the B's clearly seem to be breaking it. Right here, this gap is larger than this gap. Then this gap is larger than this gap. This gap is larger than this gap, and it just keeps snowballing. And this issue clearly happens when the object on the left is larger than the object on the right, which is a problem because we're not cross-moving the sizes. Did you stop working on Taxi, not Catsi. I haven't seen a video on it in a while. Yeah. Taxi basically became my pet project instead of being a main channel project because I don't have enough time to put the adequate care to it. Eventually, I will return to Taxi, and eventually Taxi will be a much larger project that will be way more fun. But unfortunately, right now I don't have the time for it. That's the only reason why, unfortunately. I really would love to work on Taxi, don't get me wrong, that genuinely brings me more joy than working on the videos. But, you know, can't always get what you want. Insight right here. We moved it in properly. Another question is why add two of them together, which means that after this, when we subtract maximum, oh, wait. That makes sense. This does make sense. Do I not need to normalize it? Is it genuinely that simple? So this should be max, this should be minimum, yeah. Wait, this is the left one. Why is this the minimum? This should take the maximum. Yeah, hold on. Take the maximum. This should take the minimum. Yeah, there we go. Okay, back to the issue. Yeah, what we actually need is. I'm getting a headache. It's fine. I can crack this. This vector. These are the two vectors. Simplify them right away. Then what do we need to do? We need to move it, basically assuming that this is the origin, but what if it's not the origin? Well, let's say that the origin is right here. Then the average would be the opposite. Okay, now it's centered. So what this is doing is centering it right. Which means adding this to anything. Oh yeah, so it's equivalent to subtracting, brilliant. But okay, addition will be at least clearer. Adding it to a vector aligns the vector as if it was in the middle. Now, this means that adding this to the maximum gives us the maximum. If the rectangle was in the middle, then the maximum vector. Good. Then if we multiply it by -1, it gives us the opposite side, which means that if we then translate it, it isn't. Why is it not? This gap shouldn't exist. That's the problem I'm having. I don't know why it exists. Because in order for this gap to exist, the actual vector would have to be like this. So let's say we have a rectangle like so. In that scenario, origin on this line, this would be the minimum vector, this would be the maximum vector. Then what we're doing is we're adding them both together and then dividing by -2. Wait, shouldn't just adding them together give a central point of the box already? Because adding them both together will give a point right here. Yeah. My goodness, that was wow. Wow. That was a shot in the dark. I wasn't expecting it to actually hit. But I think it did. Wow. Please tell me it works now. I just realized that the two vectors cancel themselves out, so I don't need to actually add them. In order to see if it works out, we need something more complicated. Okay, that is correct. Now let's say that index switch, actually switch. Random value, this as ID, boolean. It appears to be correct. Okay, right. It's fine. So we have finally created the correct system for left and right. That was easy, right? Okay. Good. Good. That's good. Now all we need to do is just implement the rest, but it's smooth sailing once we have this. Because first of all, the next one is just straight up. Let me just copy it like this. That's going to be much more convenient. Second one is bottom top. And bottom top is simple precisely because let's once again try something complicated. See, bottom top will be the same exact thing, except it should actually be called top bottom, not bottom top, because then it's gonna be much easier to use top bottom. So the reason why this will be easier is because all we need to do is just switch the axis. Except backwards. There we go. And just out of curiosity, if we then do this, that works. If we do this, that also works. Okay, so this is correct. Now one thing I would like to add right away so that we don't lose it later is right here. Subtract, or add, sorry, add value. And so the default is going to actually be 0. And the reason we're adding it is because what this basically does is it allows us to control the offset. So 0, 0. Right here, as you can see, we want to. No, that's incorrect. Add the subtract, will do the trick. Except the other way. There we go. Head geometry nodes are Turing complete. What's the craziest thing you've built with them so far? I haven't had any especially crazy. Also, are they Turing complete? They don't have conditional loops, which makes the process. Hold on. Because maybe with some new additions. Well, they do have simulation, I suppose. Yeah, I guess simulation can fix that. What's the actual definition of Turing completeness? I want to see. It's called Turing complete. Computable function, yeah. Definition is what I'm looking for. If there is an effective procedure that given any k tuple of x of natural numbers will produce the value f of x. Okay, that's a bit loop-to-loop. A system is called universe with respect to a class of systems if it can compute every function computable by systems in that class. That's funny. But, so right there, just describe initial power of computer system with abstract machines. Yeah. Every Turing computer function is Turing complete. A system is one that can simulate a universal Turing machine. Okay. I don't feel like getting into it right now. So let's just say yes with simulations because that feels like it would be accurate. This is abstract this time. Now we can control this offset, now we can control this offset. Alright, good, that works. Then let's do the next one, which is center. Center once again takes into. Oh, Blender's so clever. So, the way center will work is that our A stays where it is. gets first scaled down. Add. B first gets scaled down by 0.5. And also right here, let me just add in D. Actually, let's make this more confusing. There we go. That's correct. It gets scaled down, and then what? Then the scale down gets into the bounding box. And what we want is, we want the minimum value of this. Add, that's correct. Subtract, we can leave it for now because this addition will be enough. So subtract minimum. This should be maximum. Not -1, only once all across the board. There we go. Corner is done. EF, that also works. If we complicated the EF and then CBA, whatever, that also appears to be correct. That's left, right, so that's also correct. Good. Yes, that is correct. Okay, good. So we have this. Then we're going to have E, and for E, we're going to have the append right. So the way append right will work, once again, we technically are halfway there, but practically we're way more than halfway there, because what this will do is this will effectively just mimic our left and right system with one slight twist, which is that at the end, actually, is there a more clever way to implement this? I suppose there could be. If we just at the end translate the entire thing by the way we've offsetted the A, like so. Obviously we have to multiply by 1. Then yeah, that's correct. Then append left. F. Let me swap this just for the sake of testing it more. Append left, and the way append left will work is we're missing an offset. No, we're not. I hope we're not, at least. And the way append left will work is same exact idea, except we're going to swap it. So we do this. Oh, that's not correct. Yes, not correct. Or is it? No, it is. My goodness. My own system is more clever than me. That's good, that is correct. Wow, this is a really good setup. Oh my goodness. We're almost done as well. The only thing, two things we'll be missing is the top down, the append top, append bottom. So, append bottom, append top. Append, we're gonna try to knock them both out the park in one fell swoop. It would be impressive if I do manage to. So append top. Wait, no, first is append bottom. Which means we need to correct for the second one. So right here, we multiply by 1. And then right here, we multiply by 1. Let's see. That is correct. That is also correct. Okay, so all the positioning appears to be correct. Right here we can push this, 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 and that does actually affect everything further later on. Right, this also works, this also works. Beautiful! So, hold on, I'll be right back, I just need to do something quick. My goodness gracious me. What's gonna be next? Well, next gonna be actually... Yeah, next we are going to have the operations because the additions should be easy to implement. Making the plus look nice is gonna be the only struggle, I would say. But even then, it shouldn't be that much of a struggle. So let's try it. So, A plus B. Yep, it works. It may not look like it, but it works. That's because there's just a 1 in the offset, which back then I thought that 1 would be the unit heap, and whereas right now I know it will be 0. The plus is a bit low for some reason. I think that's the problem with a font though, because I'm pretty certain this should be very similar to A plus B. Let's see. Yeah, you can see plus is just low. But right here we're using append when in reality what we should use will depend. Ah, shit. What's this problem? First of all, let's just use, for now, append left and append right like this, and let's compare the two. Yeah, you can see that the plus is just low by default. And I just genuinely don't like the look of it, so I'm gonna just change it. Because this looks better. Now, the two options we'll have is either append or center. Or actually, there could be a smarter system to do it. I just don't know if it's worth it. Hold on, I have a ping on Discord, let me see. So. I have one idea on how to do it. That's in a way that's clever, which is I could keep it appended by default, like so. Then take the bounding box, get the center and offset. You are surprisingly calm given everything that's going around the world. Yeah. That's true. Alright. Another cup. Aren't you concerned that your charity may perform poorly War 3 breaks out? How should I put this? I've been living in a constant state of expecting bad things to happen for the past 5 years. I'm not calm because I'm not concerned. I'm calm because I've grown used to it. Yeah, World War 3 may break out. What would you like me to do? Until this beautiful green marble of ours stops spinning, I'm going to act as if it will just carry on. Because what else is there to do? This isn't quite correct, but actually vector mix. My goodness, what am I doing? Mix vector, just so much easier way to do it. There we go. Or maybe it isn't. This should be the minimum, this should be the maximum. Add them together and multiply by -1. I'm pretty certain that's through center, should it not? Alright, so it is actually different from mixed vector. Here's a fun hypothetical question. In case 1% chance everything goes wrong, what really in fact happens? How do you plan to live through it? What would your life look like? Well, that depends on what happens. For example, if it is a nuclear holocaust, then, you know, I'm not really exactly planning to live through it. I don't think there is an option to live through that. So it very much depends on the form it takes. Oh, that is broken. Oh wait, that's why it's broken, it makes sense. There we go. Let's say it's conventional World War 3. In nuclear, there wouldn't be a hypothetical level in the first place. Yeah, that's what I'm saying. Conventional World War 3. That's a that's a bit of an interesting sentence there. What do you mean? Because conventional World War 3 would basically implies like, oh yeah, make it. Just look past at all of the World War 3s that happened and then decide based on this. Bit grim, but no. Right, now we need the addition to appear differently. Or at least we'd like it to appear differently. Or maybe we wouldn't. Maybe this is fine. Maybe I'm overthinking this. Because then subtraction is really trivial. This is the same thing, except with a minus. That is disgusting. That is a disgusting minus. Oh, you are mental if you think that's what I'm doing. Got another thing coming. It's shameful, that was the plus and this is the minus. It's still going to be slightly disgusting, but well. This is at least better, it's still awful. This one. Thank you. Actually, the other way. Slightly better. Alright, slightly. Still disgraceful. This bothers me, the fact that B is higher up for some unbeknownst to me reason. Why is it higher? It's always something. Addition has the same problem, good to know. Maybe that's why. But this time what's nicer is that right here we can do mix vector. Like so. On a separate topic, do I need to resume? Do I need to resume to apply for volunteering your charity? Yeah, we're trying a more broad this time because last time it was a very, how should I put this, hesitant addition. Last time, the only person I've included was Adrian, because Adrian has been appearing on live streams a lot, and so I just thought it was a fine test. But I think this time we're adding a lot more people. So this time if you send an email, we're most likely... Speaking of, actually, I should check my... I haven't checked my email today. I woke up and right away started the live stream. I probably should check my email. Okay. Or maybe I should just... I'll do it after the stream, actually. No, we're not going to be distracting ourselves right now, especially as this is going on. So far, a lot of people applied, a lot of people we've included, and we only have one who's actually helping the charity. And that process is also really slow. I do have to say, the volunteer work is a lot less helpful than it would seem on the surface. So far we have 1, 2, 3, 4, 5 people. I'm effectively teaching how to do stuff. And only one person who is very slowly helping, but slowly, very slowly. But oh well. Next, what we could have would be division multiplication, I imagine. Multiplication will be easier. Actually, let's spice it up a bit. Right here, by having mix rotation, like so. it up a bit. Nice. Hi, the Quasar. I wish I could help more, but time is always so limited. Don't worry, I have the same issue. Don't worry, I wouldn't ever feel bad for someone not helping. I understand that that's the point of helping, isn't it? Willing. Would it still be open in the summer? Most likely, yeah. I would imagine it would be open past summer as well. I would only like to help charity if you let me list that as work/volunteering experience. I imagine. If someone, I do plan to do that sort of thing, where if someone actually ends up joining in the charity, learning, and then volunteering in a way that actually contributes, once I see that they have contributed enough, like once I see that they have contributed in a way that I actually find impressive, I have it written in the founding document. I'm just gonna issue a certificate. There's gonna be a certificate, slice of pie charity, that just shows you that you have gathered certain skills. Simply because I do know that the job market is a bit fucked. So I figured this is like a really nice way for me to actually help people who end up volunteering. At least I hope so. I hope it would be. Alright, there's another one. The next one, which would be multiplication and then the dreaded division. Division. Should be 2 and 3. Very nice idea. So was Katsi joking about Terraria? Katsi got a bit too excited too quickly. They weren't joking, but I don't think it's actually something that we would do. It was just a random thought Atomic threw up in the air yesterday. Sorry, people. Ancient biscuits that could buy us help land about 5 people some jobs. Well, that's good to know. I mean, I get some work experience. It's unpaid work of volunteering. Yeah. But I am gonna say it outright right now. I don't lie. I don't like lying. Well, hold on. Yeah, no, okay, that one negative screwing me. I don't like lying, and I will not lie. I will issue those kinds of certificates. I am more than happy to do so. But I want to do that simply because I see someone who has skills and I want other people to know that they have skills. I want people who have abilities to be recognized for those abilities. That is something I really want to happen. But I will not lie. You first would have to show me that you would have those kinds of abilities. Multiplication is also going to be trivial because multiplication is going to be this. My goodness, I can't press the control button. There we go. Beautiful. Multiplication, and then right here, I could just add in the multiplication symbol, I suppose. That will work. Well, if you guys need one, feel free to let me know. At this point, like, we could just... We have access to your server, we could just set one up. I could rotate this, but that's gonna be horrendous. This font does not have a times symbol, which is a problem. I feel like rotating it is not going to look good. Yeah, exactly. It specifically is italic. The italic strike again. Oh, those goddamn Italians. Wrong order. Horrendous. But it could be better than just... Should be fine. Alright. One last thing I would like to add also, actually, before proceeding, would be a control value for offsets. for especially weird things. Remove from frame, yep. I don't know, I was staring at the wall for 5 minutes straight, then decided to make a model of plant growth and tropism. Can be weird. I didn't know this weird. Well, to each their own. Who am I to judge? Not remove from frame. Quite the opposite. I wouldn't like, in fact, for all of you to be joined in a single frame. Okay, splendid. Then this one will be the basis for division, because division will be a fair bit more annoying. That's because for division, first of all, for the first time ever, we will not need append right, we'll need append bottom twice, like so. Then we need to add a bit to it. Ooh, this means that B is a center. Why is B a center? What? That doesn't make any sense. Right, but doesn't matter. What we need is we need 2000 subtraction. What? No. Vector math. Subtract minimum from maximum? I think so. Separate x, y, z. There we go. Now, actually this, yeah, that's correct. This, then math makes greater than. If x is greater than, if this x is greater than this x, this will return a 1, which means this will have to go here, this will have to go here. This will give us the size of the greater x, and then that is what we want to use for the size of the cube. However, let's see. Wow, it's almost as if I know what I'm doing. That is correct. I don't like how thick this is though. There we go. And one last thing, which is right here, we can subdivide it once more. There we go. Was that too trivial? That's not how division is usually noted down in mathematics. Usually it's just using the fraction notation. Okay, good. Now, one last thing I'm going to add for now will be just power, and power will be really simple. That's because all that power will effectively do is just, it's actually gonna be really, really trivial because it's just gonna be this. There we go, that's all it's gonna be. That is absolutely all that's needed. Let's see. Power. I use the factor for it. Oh shit, I forgot about the factor. Okay, I used the factor for it when I should have used the offset, and then we also need to obviously factor for scale. Let's see. Yep. This is incredible. This is really, really good. As far as node setups go, this is one of the better ones. The one last thing I will do is right here, store named attribute, eColor, brightness, actually alpha can just stay. Where's this? Okay, good. This has been an extremely productive live stream actually, because this is a node setup I will use for so many videos. You see, normally this is what the volunteers would do, but since no one yet is actually skilled enough in Blender to do this, I need to do it myself. I mean, okay, Adrian is close, but still, it would take Adrian more than 2 hours, which is why it was just more efficient for me to do it. Good. This is it, yeah, this is it. Because right now, so originally I noted down an equation, which I've removed, but the point is that right now I can just remove this, and then we can do something like x, y, z, and we can do division, like so, then addition, x plus y, division by z, even better, this can be power, and this can be a 2. Oh, that 2 is problematic. I have not looked into numbers of this font. That is problematic. Okay, for now let's see if it works enough, and then at the very bottom let's just do multiplication with z. But the point is, right now we can animate all of this, which is quite nice, like so. As you can see, beautiful control of everything. But I cannot let it go. We need to handle the numbers because the numbers are rough. So let me first see if check if a given string exists within another string. Beautiful. Starts with no, contains, and then there has to be an easier way for strings actually. We need to just check if number of times a given string occurs in that string. No. This might be as good as it gets. Alright. I'm not an animal, so I'm at least gonna do it like this. Or okay. Simply because it's faster this way. Go, and then we check if a number is within a string. If there is, that means we're going to actually switch. There we go. And what we're going to do is we're just going to use a different font. Ideally a font that doesn't include numbers which look like that. So we need to find a font that uses decent looking numbers. These are all horrendous. And this, nah. There we go, this right here. What happens if we change all of them to be, yeah, horrendous. Okay, so we have first font for the letters, second for the numbers, should be fine. We cannot mix together numbers and letters because then it breaks, but that can be easily fixed because we can just position them, right? So let's say that if we want position, if we want to have 3 factorial, what we can do is we can just do this, like so, and it works. They're a bit close, but that's fine because that's what we have the offset for. Which means that if we don't like how close certain things are, we can just spread them further apart. There we are. That works. That does work. There we go. Which means right now we can work with equations very conveniently, which will be great because in the past, whenever I had any kinds of equations just appear on screen, what I would do, actually I can show you, see why not. What I would have to do is I would have to manually move them around like a caveman. Hold on, let me open recent, like, I don't know, 3. Does this have anything? All of those equations right here, I'm just manually moving them around. This is ridiculous. We don't live in the dark ages anymore. We can use computers to do the work for us. But the point is, this right here will be an absolutely brilliant setup in which we do this, and I'm going to actually save it right now as defaults. Make the current file default stub file. Yes, overwrite. Beautiful. Think about it. You're the most likely to survive a nuclear fallout. Not only are you good at all sciences, you can build anything. Just survive or frozen veggies forever. I doubt I'll be able to survive a nuclear fallout, but I appreciate your optimism. All right. Let's try something out. So for example, let's go into the shading. Let's pick some kind of nice looking texture from my pack of different textures. Where are they? Yeah, you should do the trick. There we go. Splendid. I can imagine you walking around the Fallout with headphones listening to some white girl music. I would listen to The Wanderer. I kind of want to do what you do, but organic chemistry or something before that Angel and Blender. Goodness. Once again, I could teach you Blender if you'd like. If you want to work for the charity. Alright, let's bring the equation out. Oh no! Oh, well, not quite a no, that's fine. We can just do this, make group, and then just copy it, and this would be color, like so. And then we can just do this, and right here, where there is division, somewhere in this node tree there is division. Let's move this back. This cube. This, and then the cube for subtraction as well, right? Not cone, color. There we go. Sweet. So, if I move this ever so slightly lower down, like 0.5 for example, slick. Then I can remove this entire thing, and I can just do A and B, and we can do addition, and we can plug this in, and we can do this. Right away, I'm gonna already need to use LaTeX because I need. No, this is upsetting, but not bad, not necessarily bad. Do you use diffuse for the glow? No, no, I just use standard emission. There's non-empty saturation for now. We'll just call numbers. Oh my goodness! I've missed out on one of the one of the more crucial, actually, kinds of operations. I just realized. Well, that's messy. Equality. That's a
Hello, everybody.
Hi there, Katsi.
Hi.
I missed out on the equality.
How you doing?
Decently well. Being actually pretty productive right now. There we go.
Well, good for you.
Yeah, nothing needs to change. Splendid. Audition. I think before learning Blender, I need computer to actually use Blender. I mean, yeah, that is. It is easier to use Blender on the computer than it is to use Blender without the computer. In fact, I will say.
Well, no, you can use Blender without a computer. You know.
Yeah. Okay, so here's what we will do. I actually need to think about this for a second. Yeah, we'll scrap that for now. That will not be relevant. And for now, we will do. No, that's highly misleading. We're going to add a curve. So we're gonna subdivide, and then we're going to blobify it, like so. That's the proper scientific term. Splendid. Before that, I need money, and then I need a job, but the job market is trash. I blame the French. French are the last people we should blame for this sort of thing. Well, people in the quotes, obviously, but you know, there is a lot. Say about French what you will. I know I would, but like the job things, they're actually pretty. I would say they nailed it down, kind of. With their strikes and revolution, all this stuff. What did the poor French do? Well, they exist. Cheers for that, Panzer. This. Cool. There we are. fine. And so as such. I mean, honestly, this has been such a productive live stream for me. Not just with the work part, it's just the fact that how useful the work I've done today will be. Incredible. Okay, now let's join this. And then on the inside right here, we're gonna have a very similar kind of situation, except they will be slightly dimmer. And they will have a slightly more randomized color based on the repetition. So saturation, how can I combine color and then saturate color? This will be the color. HSV, hue, saturation, and value. And then this. Alright, and then drawing. Now, first thing I'd like to do is I would like to. Why am I doing a repeat zone like an amateur? My goodness. Oh, it's because it could actually break without it. No, I take it back. The repeat zone. It's fine. This. But I don't need to color up. It's just this.
I mean, if you say so.
Yeah, even then, making you humble in this whole opinion. Should organic chemistry be taught in 3D or 2D? I don't think it's relevant. That's my humble opinion. I think organic chemistry should be taught well. we shouldn't. We shouldn't.
You don't think that the D is relevant?
Yeah. So I could actually do it in a much better way. String like so. D, there we are. And then 30, so why not? And then another one should be integer for this was alright, splendid. Now what I want to do is I want to actually make it so that they are all inside of the curve, which a lot more easy on paper than reality. Because I know how to figure out if something is within the curve using an array, for example. But even then, that's a very shitty approach. In my opinion, should be top of both. In my opinion, it's irrelevant. Picking, it's... how should I put this? You should think more about the explanation rather than the medium you choose to present it. I prefer Blender as my medium, simply because Blender is really goddamn good at presenting anything you throw at it. But it doesn't matter, the actual important part of the explanation is the explanation itself, not the way you choose to present it. Where's the easy way? And I think easy way is what I should actually go for this time. Which is, we roughly align them. Like so. No, that's gonna take ages. Well, that's fine. And then we just roll tilde in. Or even better, actually. You can draw it around. This is horrid. Horrendous method. I think what we should do is we should just roll till we like their distribution. Something like this, for example, could work. Then vector math, move them so that they're more in frame, like so, and only then and close them. There we go. This works. I'll do it anyway because we're on a freak note. It's not about doing both, it's about figuring an explanation first. I spent 2 days mulling over the cross product just to figure out how to explain it. And only then have I actually begun working on the video about the cross product. Because the explanation has to come first, the more important thing. Now take this random value and then hue, math, add this, add to this, and this should be minus 0.1 and 0.1, very small differences. But we would actually like the two not to be different, now I think about it, yep. Not this. There we go. Is this good? I would say so. I would say it's pretty decent.
Okay.
So color lump like so. Math multiply 0.1. Not necessary, but hey, let's go with it. This way, this way, this way. This divide by 3 and then add. Actually, instead of multiplying it, let's. What is the character slash flag in the corner? Can't see. You have a question.
What? It's the country or then where girls come from. Well, no, it's not that one. It's the non-binary flag or the non-binary flag. Very nice, I know, right? Do you have a better answer for the question?
No.
Okay. Then take it from here.
There we go. Or this. So compared to 21. Or compared to 20. There we go. And then the other one, which will be 11. Alright, so I'm pretty certain. There we go, yeah. 23. Distribution is still a bit shite, but it happens. resistance should be minus 25 divided by 3. Wow, it's almost as if I know what I'm doing.
In a way. Now what he's making.
There we go. That works. So let's render. My goodness, this was a productive stream. Hi there, Adrian. Hey, you're stealing my job. It's not Clankers replacing us, but Maker replacing us. I literally, this stream, I said that what I've been doing throughout the entirety of this stream is something that the volunteers at the charity should be doing, but unfortunately there is no one who can do it quick enough yet.
Yeah.
Actually, Adrian, let me show you what I've done, because you may actually recognize the core idea. I have created, let me just give it a second to load in. There we go. I have created an equation maker, like so, which you have an equation, and very crucially, if you look at geometry nodes, you can animate it like so. So you can, for example, have the power disappear, you can have the division disappear, you can have the addition disappear, you can have the multiplication disappear, you can have this division disappear. So you may recognize this. Right, at least. A good friend of mine gave me his old PC and I was busy with that, but I think today I'll do an exercise. That's good. That's good. I'm glad you got the new old PC. That's nice. All right. I'll be brutally honest, it might be it for this stream. Because I kind of just did what I was supposed to do, and now all that there is for me to work on the other things I need to do today. And those other things will require me to... Well, I can't disclose them. Secrecy and such, you know. I'm already pushing it, considering the video that I'm working on right now. I must say that macOS as an operating system is 1,000 times better than Windows. Yeah, but that's only because macOS was based on Linux. That's the only reason. I'm pretty certain actually, it might have been Unix. Close enough, same difference.
Same difference.
It has the same structure as Linux, the point being, which is why it's better. Windows structure is just really off-putting. Before you go, one thing. Yeah, sure. What is it? I don't have the Taters Watch status on the charity Discord. Maybe we could change that.
The what?
I don't know. Adrian, keep working and I'll see what I can do. But for now, that'll be it. Thank you everyone so much for watching and have a great day. Bye.